let's go through LeetCode 1970. Last day where you can still cross. For this question, it gave us an integer row and a column, which forms a grid, and also two-dimensional array cells. So at the beginning, for this row and column, we have a grid for each of the element in it. It is 0, and for day 1, it put in cell 1 1. It is actually, you see that this is the 1 base index. So just for our tradition, that is index 0 0, to put a cell to it. It says the 0 represent land, 1 represent water, and the day 2, there is water at this part, and so a person can still cross the land from the top to bottom. And at a day 3, there is a water here, and in this case, we will see there is no path that the user can go from the top to the bottom. So it will return the last day he can cross. So this will be 2. Let's look at next example. This example, day 1, day 2, right? Day 2, there are water here, and he cannot cross. So last day is day 1, so you return 1. And the example 3, which is row equals 3, column equals 3, and water like this, right? So at day 1, 2, 3, he can still cross, but at day 4, when here there is a water, it blocks the path, cannot cross. So it will return 3. So for this question, intuitively, what I would think about is that we try to see for each cell which have the 0, right? If we try to see whether he can pass it, is that from the first row, find out all of the land, right? Trying to do BFS, trying to see whether they can reach to the last row. But doing like this, we need to do row multiple by column times BFS. All right, so let's look at the time complexity for this kind of approach. Well, say it has this multiple by this. The time complexity we may not be that good, right? And 16, right? So that will be outer limit. Of course, there is someone thinking whether we can for the date. We don't need to iterate m multiple by or row multiple by column times, right? And we can use a binary search for the date, and binary search binary search that will have a square root, right? And then BFS for each, for example, we try to see M row multiple by column and -1 from this state to this state. This may pass the solution, right? But maybe this is not the optimal. What we're thinking about for this question, this is very similar to another question called falling bricks. Falling bricks, hit above falling bricks. And this is simpler in that question. We'll say it says that there is some conditions. This cells, the length is row multiplied by column, and all of the values in the cells are unique. That means in the last day, all of the cells, they are water. 1, 1, 1, 1, 1. And we, from the last cell, was the last day is row multiplied by column -1, right? So we do reverse, trying to see, for example, of course, the last day we cannot cross, but we'll say the next or the row multiplied by column -2, right? After this is from 0 index, right? Not because we have to convert in index. Then we can convert this one to a len, right? So we can try to see if we convert the water len by len, trying to see whether one day when we convert, we can have the up and the bottom connected. Then if we can have for that day, we just return the day which has the top and the bottom connected. So for the connection, right? Beside the BFS, we can use another data structure called the union find. Union find, yeah. And for every cell in this grid, we are going to use a further index to put the further as itself as well as itself. And for this kind of grid, there are row multiplied by column element, and we need to add 2 more elements. One is the top, another is bottom. So we can have the union find has integer array equals row multiplied by column +2, right? So so doing like union find, every time we convert a water back to land, right? We just union all of the land. For example, for some day, I convert our water to land. What I do is that I look at all of its neighbors. If its neighbor is also a land, then I union them, right? And also, when it's converted to land, if that is the first row, we need to union this element, right? We'll add it for at top, and if we the land we add is on the last row, we also need to union this element. So every time we add elements, trying to see use the union find, trying to find these parents and these parents, if they are the same parents, if they are the same parents, then means the top and the column, they are union. So doing like this way, because union find every operation is like a constant star log something, right? So that is smaller than equal to 5. So our operation, we can consider it as a constant. So doing like this way, the time complexity will be row multiplied by column. So let's begin to write code for this. I'm going to create a help class called union find. And we need to have a parent father array, and we have constructor have n. Okay. So I have father equals new int n. And initially, what we do is for this kind of int, I put there as smaller than n, like plus plus. I have father equal to I, right? And we need to have two have functions. One is called union, int a, int b, right? So if let's say int fa dot a by a equals 5. Now I'll write a fun function as well. Function fa equals 5 b, right? So let's say if for fa dot a doesn't equal to fa dot b, that means they are not connected. Then we'll have father fa dot a. Let's point to b's father. Okay. Father of b, right? So we also have an int 5 int x. So I have int fa dot x equals father x. Okay. So if x equals fa dot x, it just return x. Okay. Then what we are going to do is that we'll have father fa dot x because we need to have a recursion, right? Find fa dot x. What we need to return is father fa dot x. Okay. So this is a union find help function. So for this question, what we need is that we need to have a grid, right? Have this grid function, a grid to be new int row column, right? What we do is that we from the last state, that is when all of the cells are placed on the grid. So when that happens, everything in the grid that the value will be 1, right? So one thing we need to take notice about this question is that we need to have the initial value. Grid row, okay, in grid arrays fill grid row. Set this one as water, right? As everything as water. So what we are going to do now is we need to have a union find have function, right? Union find uf equals to new union find row multiplied by column. This will be every cell represent. We are use an index to represent every cell in the grid. And we'll add two more elements. One is the top. So we'll say 0 to row by column -1 to cells, right? And the index row multiplied by column. We'll put this one as the top. Okay, row multiplied by column. Plus one will use this one as bottom. So what we need to is from the date, right? So int I equals row multiplied by column. So that is the cell or cells length. -1, okay, -1 when the I greater equal to 0, like plus, right? So we'll have yeah, okay, equals cells I, right? So we'll see for this cell, and the index is one base, right? But what we like is 0 based. So I have int row equals cells 0 -1. Int column equals cells 1 -1. Okay. So we the last day for example, we add our water, and we reverse is that we add the land back, right? So we add the land back. So we'll say for this index, okay, index equals the row multiplied by column plus C, right? So we'll say if for this row equals 0, that means that is the top, right? We need to have union find. Union what? Union index and row multiplied by column, okay? And let's say if this row equals row -1, right? The last one, we need to have this to union index row multiplied column plus 1, right? And now what we need to do is that for this, when we add back this land, we need to see whether its neighbor is land or not, right? So in this case, we need to have a private static int static int that have d row equals 1 0 -1 0, and the private final static int d column both 0 1 0 -1, okay? So we try to see whether its neighbor is a land or not. For int k equals 0, k smaller than 4, k plus. Okay. So we are going to have int new row equals row plus d row k, and the int new column equals column plus d column. Okay, bye. Let's try to see whether this is out of range. So if new row smaller than 0 or mu rho greater equal to rho, or mu column smaller than 0, or mu column greater equal to column. And if this grid here we need to have this grid row column equals to 0, right? Add this one as a len. And if this is water, right, we need to continue, right? We don't need to union. New grid, new row, new column equals to 0. Equals to 1, right? If this is 1, means this is water. We need to continue. Otherwise, we are UF union index. Now we should have new row multiplied by column plus new column. Yeah. So after every time we do this kind of check, let's say if UF find the top is row multiplied by column, and then the bottom is row multiplied by column plus 1, right? It will do this equals UF the find. Right, means they're connected. Then we'll say so this is for example index 0, 1, 1, 2, right? So at the index 2, we add for example at the index index 3, okay, we add our water, right? So that means this I at index 3, if we at index 2, we are connected, right? So day index 2, that it will be I minus 1, right? But these days, they are from index 1, so we'll return I minus 1 plus 1. So we'll return I. Okay, so this is actually I minus 1 plus 1, right? So that is index I minus 1 is the index which are connected, and the day is from index 1. Okay. And in the end, we can return 0. Yes. This is cell. Okay. This is cell. Yes. Should be minus. Okay. Let's use example. Okay. Doing like this, the time complexity will be row multiple by column and have a star log something. This is a constant, pretty much like a constant. So we'll say it is row multiple by column. And the space is we have a grid, right? So that is also row multiple by column.